Hi everyone, my name is Simon, so I'm one of the senior engineers in Leash. I don't have a lot of cool and flashy UIs to show you guys today, unfortunately. My work can kind of look a little bit boring if you're not deeply technical, and if I do my work badly, then it can look exciting in all the wrong ways. So I work on our SDKs, I work on a lot of comms protocol stuff, so I don't get to see browsers very often. So today's exciting for me. Today we're going to talk about streaming. We're going to talk about why we're excited in all the right ways. And we're going to talk about why you should be excited, also hopefully in all the right ways. And after I've convinced you that you should get streaming in your life, we're going to talk about how you can get it. So what is this? I've given a quick crash course on this cool word, streaming. Streaming is a bit of a deep technical conversation. Again, I don't have a UI to show you. We're going to go in a little bit deep around some technical topics today. So I'm going to ask a little bit of patience from the nerds. If you're sitting with a deep technical background, you kind of already know what I'm going to be leading into, but I know not everyone is technical. So we're going to level the playing field a little bit, and that's so we can go on this nerd journey together. It's polite. So if you've never really thought about it, Unleash can look a little bit like this. You see this cool flashy UI, you turn on a feature flag, and then suddenly magic happens and the behavior in your system changes. That mental model is not going to serve us today. So we're going to have to dig a little bit so that I can understand, so you guys can understand how this works, so you can understand what we've done. So streaming is an alternative mechanism to sending data to the SDKs. In practice, behind the scenes, what this looks like is a little bit like this. There's an Unleash server. That's the thing that runs in our systems. There's an Unleash SDK. An SDK is a little software library that gets embedded in your system, the stuff that you care about. And these two things communicate with each other. So they send updates back and forth between one another. Every time something changes on the Unleash server, the SDK must get informed about it. So of course, this is a little bit involved. Sometimes juniors ask me, what exactly is this? How does it work? So the way I kind of like to explain this is kind of like an SMS conversation. If you're looking at polling, and this is historically what SDKs have been doing in the past, it kind of looks a little bit like an SMS conversation. The SDK reaches out to Unleash and says, hey, you have any updates? Unleash says, no, nothing's changed, bro. Hey, do you have any updates? No, nothing has changed. Hey, do you have any updates? Nothing has changed. Stop asking me this. So the problem with this is it can get a little bit laggy. It can get a little bit chatty. I'm being intentionally vague about those topics because we're going to unpack what they are a little bit later and what they mean to us. Streaming flips this conversation around. So instead of the SDK asking if something's changed, Unleash can just tell the SDK that something has changed. Because Unleash knows all the SDKs that are connected to it, it can track them, it knows what updates they need, and we can do some cunning little optimizations that lower the data that needs to be sent. For the nerds who kind of on the call, we're using SSE, server sent events, to send this data down to SDKs. Boring, robust technology. So demo time. Never trust an engineer if they tell you they've made some stuff until they can show you exactly what they've done. So today, I've done what a responsible engineer does in 2026, and I've vibe coded a ball of goop to show off a cool technology that we've built. On the left-hand side of my screen, you're seeing a very simple system here that is two SDKs connected. You can see the streaming SDK here. We can see a polling SDK here. This, in practice, would be your system. Your system's not going to look like this. It's not going to work like this. Pretend with me. On the right-hand side, we've set up an Unleash system. So this is running on my machine. And I'm about to connect the two so that our new little test system can see flags that are coming through. So we're going to start both SDKs. And thank goodness it works because the demo god's on my side today. So right now, you can see the streaming SDK has received data. The polling SDK has also received data. And they are talking to this flag here that I've got on the right-hand side. If I flip this button, straight away, instantly, you can see the streaming SDK has immediately got the information changed. Unleash was smart, it was clever, it sent the information down. The polling SDK has been ticking away in the background, waiting for its chance to shine, eventually reached out to Unleash, kind of got its update. Flipping the flab again, same thing. Polling SDK was a little bit fast this time. Sometimes polling cycles work like that. So that's kind of a loose crash course on what streaming looks like in practice. Let's dig a little bit further. So what does this solve? My favorite question as an engineer, why did we do this? What does it solve? Engineering is driven by the whats and the whys. It's driven by what technology can do to solve real problems. It's not all about looking flashy. Sometimes it is about looking flashy. So 3 tiers of benefit. Now that I've disparaged looking flashy, looking flash is pretty cool. So the changes that come through in streaming are near real time. I'm not going to say exactly real time. That would be a little bit of a lie. Rollbacks are immediate. Changes happen rapidly in demos. Developer ergonomics are very nice. Now I say this as someone who uses Unleash on a daily basis. Every now and then you can turn on a flag and you sit there and you go, did I actually flip that flag? Waiting for it. Oh, there it is. And we get asked this question in support calls from time to time as well. Why is this flag not? Oh, never mind. There it is. It changed. Streaming makes all of those things go away. So your flag updates are instant. If you're dealing with complex daisy chaining systems, like if you're using Unleash Edge, and you've got 4 or 5 layers of daisy chaining, this can represent 30 seconds of waiting across each of these chains. So in practice, about 2.5 minutes. That's a lot of waiting. This is kind of like a real life setup. We do see setups like this in the wild. Probably don't do this unless you need it, but it is a real risk sometimes. This does happen. Again, streaming will propagate these changes directly through all of these edges like a second. So it takes an entire bunch of pain away from this kind of setup, which is really nice. Second big reason, this is a little bit more nerdy. Streaming is much nicer to your hardware. So this is the kind of stuff that I was talking about earlier that I was vague about. Streaming allows us to do some clever optimizations. Instead of sending this very large chunk of data down to the SDKs, streaming can send a very, very minimal diff, and it can only send it when it needs it. So instead of sending like megabytes and megabytes of data, you're kind of looking at like this kind of stuff. So we do see payloads in the wild that are multiple megabytes. That's generally not advised. I suspect some people in this call are doing that, and I suspect we've had a conversation about it. You know you are. I'm not judging. It does happen. Streaming makes those kind of problems go away. So in theory, like there's very, very large setups where you're dealing with thousands, hundreds of thousands of toggles, thousands of SDKs. This can bring performance back to your SDK, back to your setup without causing you a ton of pain. So these kind of things can be important in some setups. Third tier is control. And this is kind of like the stuff where I start to get really nerdy. So streaming comes with a bunch of benefits. If you're already looking at this kind of stuff and you're aware of how your system works, you know how feature flags are used, you have a sense of when they change, how often they change, what kind of changes are propagating through, you know your network, you know your CPU, you know your memory usage. Then you're kind of looking at this kind of system, you're going, I can make some very interesting trade-offs. Very large systems can benefit aggressively from those. I'm not going to go into too many details around these because if you're looking at this talk and you are the person that I'm talking to, you probably already know better about what benefits you can get from this than I can. But we do see real systems in the wild that can benefit from this kind of technology. So kind of want to slow down a little at this point and talk about why. And I want to be careful at this point. So we've never been a no on streaming. We've been a not yet. And there's been a very intentional reason around this. Streaming is a difficult technology to do well. Polling is boring and robust, and we love boring and robust technologies because they don't wake us up. I've seen this go wrong in the wild from other engineers that I have a lot of respect for. And I say this not to disparage those engineers, but to help you guys understand that even people who are very good at these kind of things can get this wrong. So we're very cautious when we were moving into streaming. And I've learned a little bit of a trick from one of our sales directors. He likes to put up a quote around a relevant thing. So we're going to see a quote now from this DevOps engineer, which kind of looks a little bit like this. We don't like interesting technology as engineers. We love boring technology. We do not like to be woken up at 2 a.m. We do not like excitement at 2 a.m. It's different when you're 18 and you're at university. Having excitement at midnight is great, no longer. So we spent a lot of energy and a lot of time trying to make streaming boring for you, for us, because we use streaming as well. So behind the scenes, there's tension at Unleash. We talk about a lot of our values from time to time. 2 of our values are experimentation and trust. These kind of are tugging in different directions. Streaming is an experiment. We believe in experimentation. We believe in being bold, trying things. Innovation is important. Exploring new ideas helps us push the boundaries of what we're capable of around the value that we can add. On the other side, trust is also important to us. So we do our utmost to never break other people's systems. We also like to not break our own system, but we believe that it's important around dealing with other people's production. And we know that our SDKs run in your production systems. So we're super cautious about changing things in the space because we don't want you to be woken up at 2 a.m. So we've put a lot of work into this. a lot of guardrails have gone into our streaming protocols to make sure that they're safe. Talk very briefly around what those are. Into each of our SDKs that support streaming, we've put failover mechanisms into that. So this means the SDK will constantly monitor its streaming connection. If it detects that anything has gone wrong, anything that suggests that system cannot recover, it's automatically going to fail over back to polling, the boring, trusted, tried technology that we've been running for 15 years. So this, in theory, makes streaming quite safe within your SDKs. You can experiment with it. You can try it. If something goes wrong in production, the SDK will automatically recover from this. More than that, the SDK will also inform you that it has done so through its event logs and its event streams. So it will let you know that it has failed over. If that happens, let us know. We'd like to know about it. The second thing is hydration. So on the unleash side, if anything ever goes wrong, we detect that an SDK is off by one, it's got the wrong data, whatever it may be. We don't play around with this. We send an entire forced refresh. So this is basically us forcing back to a polling mechanism very briefly. And the downside of this is it can increase the amount of data that is being sent to your SDK. The upside of it is, well, production doesn't go down at 2 a.m., which we really, really like. So this is the kind of things that we put in briefly while we're experimenting, while we're trying things, while we're making this safe. The third thing is metrics. So we are open and honest about this being an experiment. We monitor this very aggressively in our own production systems. We share that methodology with you. So demo time, again, let's talk very briefly around what this means. So what you're seeing here is our production system. We run streaming in our own production. So if you're not familiar with the screen, that's probably because you're not running Enterprise Edge. If you have Enterprise Edge, you should get familiar with the screen. It's super useful. This is effectively a network graph of all the connected Unleash Edge instances. So you can see we've kind of got a lot. If you expand one of these little beasts, you can see a rich amount of information around what's going on in that Edge instance, what it's doing, how it's behaving. And most importantly, what we've added here is the revision ID. So this revision ID is its streaming ID. This will tell you exactly where it is in terms of its streaming protocol. And it will tell you this nice little green color is telling you that everything is healthy. If for whatever reason this goes wrong, this will turn red and it will warn you that it's out of date, and you will know immediately that something is wrong. More than this, we share our own documentation around how we run and configure Edge. So you can see this today if you go and look at our Edge documentation. There's some pretty rich information around how we do the monitoring, what we're reasoning about in terms of alerts, how we make it safe for ourselves. We share that with you in case you're running self-hosted Edge instances. You can copy us, basically. You can get whatever we do in our production systems, you can mimic. So hopefully by now, I've convinced everyone that you need streaming and you need it tonight. I promise I'm an engineer, I don't work in sales. The good news is you kind of probably already have it. So if you are running hosted Edge, we're already running streaming in production for a lot of our customers. This means that for you, all you need to do to get access to streaming is turn it on in one of your SDKs, and it will already be active. If you're running self-hosted Edge, if you're running Edge version 20.2 or higher, you already have it as well. It just needs a flag configuration turned on. Again, this is listed in our documentation. You can read it. You can get access to this today. The sad news is we haven't rolled it out to every single SDK. So right now, this is backend only. And this is intentional as we iterate because front-end SDKs are a much more complicated project. Do we have plans to maybe do front-end support? I don't want to talk about it. Maybe. We'll get back to you in a couple of months. It's on our backlog. We're thinking about it. Today, we support 4 backend SDKs, Java, .NET, JavaScript, Golang. If you are using one of these SDKs, you can get access to streaming today. If you are not using one of these SDKs, reach out to us. If you want them, let us know. Your voice helps us choose what to build and when to build it. And that's all I have for you today. So I hope you enjoyed this. I hope you're interested in streaming. And if there are any questions, feel free to ask.
Thank you, Simon. That was great. Let me see if we have any questions so far. Looks like the audience is a bit quiet. Now, let me put also the engineering hat on, Simon.
Sure.
We talked about some of the qualitative implications, sending less data over the wire and only getting the data when you need it instead of every, 15 or 30 seconds. But the engineer in me wants to ask you, what about the performance implication? Like, can we go one layer down and talk about what does the performance implication look like in a real production system if somebody wants to switch from polling to streaming?
It's a great question. I don't think there's a simple or easy answer to this, because I'm going to say the answer that all engineers love to say is it kind of depends. Streaming can get you a lot of benefits if you're working on very high CPU loads. So part of the issue of setting very large payloads is that those payloads need to be interpreted by Edge and or SDKs. Those parsers can be expensive in some contexts. So if you're running a lot of IoT devices and you've got very tight SLAs around how lag, streaming can improve that because it's sending less data. If you are sending very, very large payloads, it can also help with your network throughput. It can. I'm not going to say it will. I'm going to say can. On the other side, there is a trade-off there because Edge and Unleash needs to track each connected instance. You can also get more memory usage. And I'm going to say can because it depends. Anytime you're kind of thinking about adopting these very large sweeping changes, I would be looking at like profile, benchmark, test it for your setup, see what benefits it provides, walk in knowing your system hopefully better than I do. And if you've got more questions than that, ask. We're always around on Slack to give advice.
All right. Thank you, Simon. So you mentioned there is no front-end support yet. And what's the best way for people to reach out if they want, to ask you something about front-end? Sure. Maybe Slack?
Sure. We have a community Slack. That's probably the easiest, quickest way. We're not super active on that. We are active on it. So if you've got a question, we'll probably get back to you in an hour or two. If you are an enterprise version of the Edge, you have access through your customer success representative. They will probably get back to you in a few seconds. So you can reach out to us through those.
Super. Thank you, Simon. Now, you mentioned it a few times that streaming is available only through Edge, which implicitly says you can't just do streaming between the SDK and the Unleash instance, right?
Yep.
Again, business model is one thing, but also engineering challenges. Can you share a little bit about, why that is not possible and what are the consequences of that?
So it's not that it's not possible. It is possible because we do that occasionally and Unleash ourselves. The reason we're not trying to push people towards that model is because we consider both streaming and Edge artifacts of scale. So if you're working in very large setups, that's the kind of situation where you need these kind of tools and technologies. If you're running streaming directly against Unleash, there's a risk that we inflate the memory on Unleash. We're trying not to do that. It puts pressure on our infra. So we're pushing all those problems off to Edge, which is why we built Edge in the first place. It is to achieve these kind of scale units. It's a half answer, to be honest, Alex. Yeah.
But that makes sense. And it also brings the next question about what else does Edge do? If for people that have heard of it, but that don't have a full picture of it. Streaming is one thing, but Edge is doing a lot more, right?
Sure. Edge does a lot of things. It's hard to kind of capture the essence in like a very, very short phrase. If I had to try, I would say it's like a very aggressive caching proxy for your SDKs. That misses some essence because you could just put Nginx in front of it and kind of get like 10% of what Edge is able to do. So Edge provides more than just that. If you're using front-end SDKs, those evaluations run on Unleash. If you're using Edge, those evaluations run on Edge itself. So you can get some very good like Edge performance. That's kind of why we called it that. Edge has also got like some resilience layers built into it. So it will persist its state to something like Redis or S3 on rehydrations, on crashes. It will load that straight away from those systems and like be good to go without any fuss. Can survive disconnects from Unleash because cap theorem is a real thing in our life. And then it manages authentication stuff. So you can run a whole bunch of complicated projects and environments through Edge via token formats, and it will automatically deliver the correct things to those SDKs. Can't really do those kind of things with caching proxies. So it's kind of like a caching proxy, but way more at the same time.
Yeah, that makes sense. I was also thinking that we have mainly discussed performance implications, but as engineers, we also need to be cost aware, especially, if you own the infrastructure side of things. And I was thinking that based on where you're hosting Unleash, maybe in your own cloud accounts and so on, and based on who is fetching those, configurations via either polling or streaming, you need to be aware of, are you paying for all that data transfer out? And especially when we go into front-end use cases, that will impact cost as well as performance. Right?
Yeah, absolutely. So if you're running Edge hosted by us, we pay for the data costs, not you. So please run streaming. It helps us save costs. If you're running streaming yourself, then obviously it's going to help you save your own data costs. But then there's always the conversation around if you're making this very large network hop across a huge ocean, you're going to suffer some lag. The system's not going to work the way you want. You want your feature flag SDKs to go somewhere very close, get that data very fast, and be done with the conversation. I don't really want to connect 100,000 SDKs to be communicating with something on the other side of the world. It's just wasteful.